two things today. First, we want to talk about this page. So it is the back of the molarity page. Have we filled that already? Go ahead and find that. So this page deals with molality. So molality is not a super common unit of concentration. In fact, in science as a whole, it's very rarely used. But there are two calculations where molality is required. Outside of those two calculations, you'll never use molality, but it's important for those. So, if we remember, molality is represented with what letter? Lowercase m. So, little m equals what? Number of moles, kilograms of solvent. So whereas molarity was number of moles over liters of solution. So for water, 1 kilogram equals how many liters? 1. So for water, molality is number of moles over liters of water, right? Because 1 kilogram is 1 liter. So we're going to write it as kilograms of solvent because we can make solutions with solvents other than water. But if the problem doesn't say, we're going to assume we're dissolving in what? Water. Okay. But for here, for molality, do I care about the total volume of the solution? No. So molarity, I care about total solution volume. Molality, I care about solvent volume. Everybody see the difference in those two? Very subtle difference, but it does make a difference there. So the exact same question as last time. How do you make a 0.5 Molal, M-O-L-A-L, solution of sodium chloride in a 1 liter flask? So same question, different unit for concentration. Okay. So just like last time, the first step is figuring out how much solid do I need, right? So step 1, calculate grams of solute needed. So if you think back to the previous example, would the answer for this be the same as the previous problem? Yeah, actually, yes. The number of moles is going to be the same. So how many moles would I need to make 1 liter of 0.5 molal solution? It's 0.5 moles. Okay. Could I convert 0.5 moles to grams? Yeah. So step 2, I got to weigh out the number of grams. So weigh out grams of solute. So for step 1 and 2, have I changed at all from the molarity process? It's the exact same. Step 3 is where it's a little bit different. So now I can measure out my kilograms of solvent. So I need 1 kilogram of solvent. How many liters of solvent do I need? 1. So weigh out 1 liter of water, or measure out 1 liter of water. Measure, I can say 1,000 milliliters of water. 1,000 milliliters is 1 liter, which is 1 kilogram. Now, with the molarity process, I had to dissolve the solid, a little bit of water, add more water, fill it up to line. Do I care about that here? Can I just pour them all together and stir them? Yeah. Step 4 is just mix and dissolve. Anything else? That's all I care if I'm done, right? Do I care about what my final volume is? No. So could I use the magnetic stir bar to stir it the whole time? Yeah. Because I don't care about its size. Just drop it in there, let it go pound. I'm not worried with the final volume of the solution. Okay? So which is easier to make, 0.5 molar or 0.5 molal? M-O-L-A-L. Yeah, the Molal solution. Okay, it kind of sounds weird to say. Because I don't care about the volume of solution. I just care about the amount of solvent that I have. Okay. Questions about that? Yeah.
Not really questions about that. For the question, the little m next to 0.5, that's molality, not mass.
Correct. So you don't say like 5 mass, you would say 5 grams.
Yeah. It just makes me think of mass.
Yeah, so mass is a variable, not a unit. So grams would be the unit for mass. It's a little bit confusing. So let's look at number 1 to go. What is the molality of a solution containing 18 grams of HCl and 250 grams of water? So what is my solute?
Water.
My solute?
HCl.
HCl. So I need not grams of solute, but moles of solute. Okay? Can you convert from 18.2 grams of HCl to moles of HCl? Yeah. So then, before you do that, I have 250 grams of water. Do I want to convert grams of water to moles of water? No. I convert grams of water to kilograms of water. 250 grams is how many kilograms? 0.25. Okay. Then you can divide moles over kilograms. Okay. So if you want to do that, you can. Just really quickly. The only confusing part here is you're going to be given oftentimes two different numbers with grams as units in your problem. The grams of water and the grams of solute. Okay, you got to convert properly. Could I also give you milliliters of water? Can you go from milliliters to kilograms if you're in water? Yes, only for water though. Well, 1 milliliter is 1 gram for water.
I don't know where the equal button is.
I'm sorry. Here, can you catch?
No.
Can you catch?
I can catch it and I can toss it.
Don't toss it to her, walk it to her.
I'm going to hand it to her, that's what I meant.
Thank you. That one was confusing.
I found it on the floor one day. All right, so questions about molality?
What do you do after you convert from grams to moles and you have a 0.25? You just
So
put it in?
moles over kilograms, yeah.
Oh,
So let's look at the bottom now, number 5. It asks us to compare making molal versus molar solutions. So we already talked about the difference in the processes, right? One process care about solvent, one process care about solution. So let's talk about kind of the final product now. So let's say have a 0.5 molar solution and a 0.5 Molal solution. Let's kind of compare those two. So let's just say 1 liter of each. So 1 liter of both of those. Will they both contain the same number of moles of salt?
Yeah.
Yes. So we can say 0.5, no. So again, 0.5 moles of solute. 0.5 moles of solute. How much water did I add to the 0.5 Molal solution? How much water did I add up here?
Oh, 1 liter.
1 liter. So 1 liter of water. But for the molarity example, how much water did I add? Did I add 1 liter?
No.
I added less than 1 liter, right? So I don't know how much, but I know there's less than 1 liter of water. I know it's less than 1 liter because I have 1 liter total of solution. Okay? That is after I add the salt. So here I have 1 liter of water. Here I have less than 1 liter of water. For the molarity example, my total volume equals what? 1 liter. For the molality example, what is my total volume? Yeah, it's just greater than 1. Because I added 1 liter of water plus some salt. Okay? So I don't know the exact final volume of the solution, but it's got to be more than 1. If I take 1 liter of water plus my salt, it's somewhere greater than 1. Okay? Questions about that? So now, if they have an equal number of moles of salt in different volumes, do they have the same concentration? Are they equally concentrated? No. Which one of these is more concentrated? This one. It's more concentrated. Because they both have the same amount of solid dissolved, right? They both have 0.5 moles. But the left, the molar example, has less water, okay? So when you dissolve the same number of moles in less water, you get a more concentrated solution, okay? Does that make sense? So in this example only worked out nicely because we used water as a solvent. Okay, so for this class we'll always have water examples. So is it drastically more concentrated though? No, it's very similar. Okay, so they're overall pretty close for water, but they are going to be slightly different in their concentration. Okay, the hardest thing for this in these examples is to recognize if your problem has a capital M or a lowercase m. Some questions will be answered the exact same either way because they have the same number of moles. Some questions it does matter if you're looking at molality or molarity. Okay? Any questions about that? So we'll come back to that in a little while. But now look at the piece of paper I gave you today. So let me grab one. And this should have been in the notes, but it wasn't. Sorry. So this deals with dilutions. So when you dilute something, what do you do to it? You're going to add more water in these examples, okay? So you're going to make it more or less concentrated? Less, okay? So let's turn over to the back and take a few notes. So our formula for dilutions, making things less concentrated, is C1V1 equals C2 V2. What does that remind you of? Yeah, the gas laws, okay? So the same general idea. With the gas laws, you get something initially, you change something, you calculate the final result. Same thing here, okay? What do you think C stands for? Concentration. V, volume. So just like with the volume of gases in Boyle's law, does what units we have for volume of a solution matter here? As long as they match, they don't matter, okay? So it can be milliliter, milliliter, liter, liter. As long as the volumes match, we're in good shape. You'll also see it written like this. M1 V1 equals M2 V2. Okay? That's the exact same formula. The M just stands for molarity. Okay? So we'll use the top one, do the same. I'll write it with the C's. But just be aware if in the future you see M1 V1 equals M2 V2, it means the same thing. M is just a unit of concentration, molarity there. Okay? So this is my initial. This is my final after dilution. So my C1 is the concentration when I start. My V1 is the initial volume that I have at that concentration. My C2 is my final concentration, and my V2 is my final volume. So that is not the volume of water added. That is the total volume. So if I start off with 5 milliliters of solution, then I add 5 more of water, my V2 is going to be what? 10. You have to add them together. There's nowhere in this formula to plug in the amount of water added. Okay? You have to do that on your own and plug it in correctly. So let's look at a very simple example. So let's say 5 milliliters of H2O is added to 5 milliliters of 1 molar HCl. What is the new molarity. So first, we all recognize this is a dilution problem. Does that sound like we're diluting something? Yeah. We're taking a solution, adding more water to it, make it more dilute. So my formula, C1 V1 equals C2 V2, big M. If it were small n, it'd be the same thing. It wouldn't change anything really. So concentration 1 is 1 molar times volume 1, 5 milliliters. I don't know C2. V2 is going to be what volume? 10 milliliters. It's not 5. If you plugged in 5, you get the exact same answer. Nothing will happen. Okay? So then you solve for C2. It equals what? 0.5. What are my units? Yeah. Molar. The milliliter cancel. You're left with a capital M for molar. So we chose easy numbers here so you can see what's going on. Double the volume. So if I double the volume, I do what to the concentration? Half it. Okay? There's now twice as much volume for the dissolved particles to float around in. So they are half as concentrated as in the past. Okay? So whenever you add water and increase volume, the concentration is always going to do what? Decrease. Okay? Will it ever increase? Not unless you take out the water. Okay? So the example would say is evaporated or boiled or something. Okay? As long as you're adding water, the concentration has to go down. So you can check yourself. If you add water and your answer has a higher concentration than when you started, you know you're wrong. Okay? And if it's the exact same, you really know you're wrong. Okay? So you can always kind of check and see if that's logical. Any questions about that? Let's look over and do one together. And we'll do something else. Let's look at number 1. So I add 25 milliliters of water to 125 milliliters of 0.15 molar sodium hydroxide. What is the molarity of the diluted solution? Does the fact that it's sodium hydroxide really change anything here? It really doesn't matter. Okay? So I have concentration 1 is 0.15 molar. What is my volume 1? 125. It's not the first one mentioned in the problem, but it is the volume of the initial solution. Okay, so you have to read the question. Equals, I don't know, C2 times V2 is what? 150. It is not 25. If you plug in 25, you'll get a concentration larger than when you started. So you should recognize that's wrong. So you plug in, you solve for C2, you should get like 0.13 molar. So did my concentration go down? Should it have gone down? Yeah, I added water, it should go down. If you plugged in 25 here by mistake, your number would do what? It would have gone up. And you should recognize kind of messed up there. Okay. Questions about that? So let's turn back over and talk about where we encounter this most often. So this is most often encountered and used if, first of all, we don't have solid sodium chloride. Let's say I need to make 0.5 molar solution and I don't have any solid. But if I have 1 molar solution, can I dilute that to make it into 0.5 molar? Yeah. Okay, so if you don't have the solid, this is our only option, to dilute a more concentrated solution. But let's say I need to make some 4 molar, some 2 molar, some 1 molar, some 0.5 molar, and some 0.25 molar solution. Okay. Let's say I just need a very small amount of each of those concentrations for whatever it might be, sodium chloride, the compound doesn't matter, for some experiment. So could I use the solid to make 1 liter of this, 1 liter of that, 1 liter of that, and just do all of them? It's an option. But if I just need 5 milliliters, it's kind of wasteful, right? And I don't have a volumetric flask small enough to make just 5 milliliters. Usually they're 50, 100, 250, 1,000, whatever it might be. Okay? So we do what we call a serial dilution. So what that means is we just do a dilution over and over again. So we start off with, we're going to make 4 molar, whatever it is. So it could be 4 molar sodium hydroxide, 4 molar sodium chloride, 4 molar hydrochloric acid, whatever it might be, in a volumetric flask. I'll draw that. So now I've got my 4 molar solution. So now instead of making a whole nother liter for each of the other samples, I'm going to get some test tubes. I'm going to get 4 test tubes out. There's test tube 1, test tube 2, test tube 3, test tube 4. So we'll call them A, B, C, and D. In test tube A, what we're going to put is we're going to put 5 milliliters of 4 molar solution plus 5 milliliters of water. Okay, so we're going to take 5 milliliters of that and put it in there. Okay, so if we take 5 milliliters of the 4 molar solution, put it in the test tube, then take 5 milliliters of water and put it in the test tube, I've done what to that concentration now? I've halved it. So what is the concentration of test tube A? 2 molar. So have I satisfied that requirement now that I need? Yeah. But I only needed 5 milliliters of it. How much did I make? 10. So lucky for us, we're about to use it. So now, in test tube B, we can do this. Test tube B, I'll add 5 milliliters of test tube A plus 5 milliliters of H2O. So if I add 5 milliliters of A plus 5 milliliters of water, what is the concentration of test tube B going to be? 1. And you probably get the picture at this point. We're going to take some from test tube B, put it in test tube C. This will be 5 milliliters of C plus 5 milliliters of H2O. So then the concentration of test tube C is going to be what? 0.5. The same thing for D. We'll take 5 milliliters of, sorry, that should be 5 milliliters of B. So 5 milliliters of C plus 5 milliliters of water. Then I have 0.25 molar. So a couple of reasons to do this. First, I only have small samples now. I just have just what I need. So if it were sodium chloride, it's cheap, it's safe, I could make 1 liter for each and be done. But if it's a salt that's either really expensive or should not be poured down the drain in excessive amounts, this is a way to use the minimum amount of salt required to make a bunch of different samples. Okay? So if this were sodium chloride, it would all look the same, right? Because salt water and pure water look identical. But if this were something like copper 2 sulfate, which is really dark blue, what would I see as I moved across these test tubes? Yeah, the color would fade. Okay, you see the dilution happen. So typically we visually don't see it because the color fades out only if there is an initial color. If we have sodium chloride, it's all going to look the exact same. Okay, but this is an easy way for us to make a bunch of different solutions with different concentrations. Yeah.
Do you just put like food dye in water? Does that like change something with the chemicals? Or that just
I mean, you will still see the color fade out. Yeah.
yeah, like that wouldn't like change anything with like the chemicals.
Most likely it wouldn't. No. Yeah. So if we think about doing this, do we have to half it every time? Could we decrease it by 25% every time? Yeah. There's no reason why I did half and half, other than I wanted to do 4 to 1.5. I could do 1 milliliter of this plus 9 milliliters of water, 1 of this plus 9 of water, and decrease by a factor of 10 every time. Okay, so there's really no limit on what you do there. Okay? Questions about dilutions? Okay, so now I'll turn back over and look at those last few problems on the front. So notice one of them, number 4, says if I boil something. If you boil something, do you gain water or lose water? So should my concentration increase or decrease? Concentration should increase here. And this one said how much water would I need to add. It does not ask for final volume. It asks for how much water needs to be added. Okay? So take a few minutes to get those figured out.